Welcome to the European Commission Directorate General for Defence Industry and Space, the so-called DG DEFIS. I'm Catherine Cavada, Director for Secure and Connected Space Activities. Technological sovereignty is one of the key drivers of the EU space policy, even more in the current geopolitical context. Together with our EU member states, we define, we fund, and we implement research and development activities, including, and this is very important, critical space technologies to be embarked on EU space missions such as Copernicus for observation, Galileo for navigation, and tomorrow, IRIS² for secure connectivity. An important focus of our research and development activities is also building the entire EU space technology supply chain at first subsystem and then component level. It is more and more essential for our industry and more needed to ensure unrestricted access to critical technologies for our EU space missions.
Hi, I'm Fabio Vitobello, and I'm responsible for critical space technologies for EU non-dependence and related R&D activities. The Commission directly implements R&D activities with EU industry, aiming at developing critical space technologies based on EU supply chains in the areas of subsystems, equipment, up to EEE components level. To stay at the frontier of space, we must ensure developments of critical space technologies within the EU that are not only pushing the boundaries of research and global competitiveness, but also ensure EU non-dependence. The harsh environment of space, including high radiation levels, temperature cycles, high reliability, or risk of collision, set higher requirements for space technology than any other domain. This is the reason why we foster dedicated space-focused developments. For years, the European Commission has defined top priorities with member states and developed key technologies with industry. For example, in the development of EEE components for space applications. By the end of 2027, we will have spent around 120 million euros. Our project officers work closely with European industry and SMEs at all relevant stages, from the review of the requirements up until design and manufacturing of prototypes and demonstrators, as well as testing and validating final products in orbit. In the last years, we have been developing a number of space EEE components. For example, this is the first EU-based radiation-hardened FPGA that we developed together with EU industry and SMEs. It is now space qualified, a success story, now part of Galileo, Copernicus, and tomorrow, IRIS². In fact, DG DEFIS has already started development activities for the next rad-hard FPGA. Here, we have the first EU-developed radiation-hard, high-density non-volatile memory in a 3D package. We've just completed a space evaluation showing very good results in terms of radiation hardness and electrical performance. We hope to insert it into the EU space missions in 1 or 2 years. Other areas of activities include advanced materials development such as PCBs with high-density interconnect technology and advanced assemblies to serve increasing complexity and functionalities of modern integrated circuits in digital signal processors, FPGAs, and other devices.
It is obvious that our space program keeps the European Union at the forefront of technological leadership, and this is key, essential, important, fundamental, the backbone of the competitiveness of our European industry.
Additionally, it is fundamental for the evolution of the EU space missions that bring so much to the EU growth and security.